lecture I'm going to talk about conditional probability, total probability, and Bayes theorem. But before starting that, let's assume that I have a problem of transferring signals. I can transfer signal 0 and receive 0, or I can transfer signal 1 and receive signal 1. But imagine that this transmission is not perfect. So probability of receiving 0 while I'm sending 0 is calculated as 0.9, and probability of receiving 1 from transferring 1 equals 0.95, and probability of transferring 1 equals 0.4, and we are asked to calculate probability of transferring 0 while receiving 0. To solve this problem, let's first start with some definitions. Consider I have a sample space like this, and I have two sets, set A and set B. Intersection of A and B we represent by this symbol, means A elements inside A or and B, which is this section, and union of A and AB, which is with this symbol, that means elements inside A or B, which is, let me show that with red, so that is this one. Okay, now let's define total probability. If A intersection B equals a null set, which means there is nothing inside that, so A and B are disjoint, or exclusive. But we should consider that A and B are not independent, because independence has a different meaning and definition. If probability of A intersection of B equals probability of A times probability of B, we say that A and B are independent. Now consider that I have a sample space like this, and inside that I have sets B1, B2 to Bn, and these sets are disjoint, so they are mutually exclusive, so there is no intersection between them. So we say B1, B2 to Bn are disjoint, and also they are exhaustive. Which means covers the whole sample space. So mathematically we could say S equals Bi union of all of the P's. Therefore, if I have one set here, call that set A, we could say set A equals set A intersection with B1 union with set A intersection with B2 union to the A intersection with Bn, like this. Now let me define conditional probability. In conditional probability, we say that probability of set A given B by definition equals probability of A intersection with B over probability of B. So this symbol here means definition, this symbol here means given. Therefore, you can easily write probability of A intersection B equals probability of A given B times probability of B. Series of sets like A1, A2 to AN, and those are disjoint. So we could say probability of intersection of these sets equals summation of the probability of each one. This is an axiom. So as all of these sets here, these sets 1, 2 to the n are disjoint, probability of them will be summation of them. So probability of A is probability of A given B1 times B1 the probability of A given Bn times probability of Bn. So this one we call it total probability. Then the next definition that I'm going to go over that is Bayes Theorem. According to Bayes Theorem, probability of B given A equals probability of A given B times probability of B divided by probability of A. By knowing these definitions, we are able to solve our signal transmission. To start that, we have the probability of transferring 1 as 0.4. We have only two things to be transferred, 0 and 1. If transferring 1 probability is 0.4, therefore probability of transferring 0 equals 0.6. Also, we know that from this one, receiving 0 while transferring 0, probability is 0.9. What would be the probability of receiving 1 while transferring 0? It's obvious that that should be 0.1. In a similar way, we had probability of receiving 1, transferring 1 was 0.95. So probability of receiving 0 while transferring 1 equals 0.05. Now, let's look at what we are looking for. We are looking for the probability of transferring 0 given receiving 0. According to the Bayes theorem, this probability equals probability of 0r given 0t times probability of 0t divided by probability of 0r. Now let's look to see what do we have from this formula. So probability of 0r 0t, we already have that as 0.9. Probability of 0t we calculated here, so we have that. We only need to calculate probability of 0r. How could I calculate probability of 0r? Probability of 0r equals probability of 0r given 1 transmitted 1 times probability of transmitted 1, probability of 0r given 0t times probability of 0t, using total probability. If you remember, those two sets right now, that is transferring 0 or 1, they are disjoint and they are exhaustive, so they cover the whole sample space for us right now. So if we calculate that, let's see, do I have all of the elements? We have this one from here, we have this one is given, and we have these two things. Okay, if I substitute in numbers, I should be able to calculate the answer. So we continue with that. So I say probability of 0t 0r equals 0.9 times 0.6. 6 over 0 r 0 3 1 3 is 5 1 3 plus probability of sorry, this is 0.9 times 0.6 so the probability is 0.96. So this means that probability of transferring 0 while I'm receiving 0 is 0.96. You might say, okay, what would be probability of transferring 0 while I'm receiving 1? So I have this one, 0 transferred given 1 r. Now this should be 1. So therefore I can calculate also the probability of 0 transferring while I'm receiving 1, which is about 0.04. So in this lecture we went over conditional probability, total probability, and Bayes theorem, and we saw that how can we use these definitions to solve a practical problem, that is transferring of a signal. Thank you for watching this video.